This lab is about continuous time Fourier transform. Continuous time Fourier transform is used to convert a signal from one domain to another domain. Let's say if we have a signal in time domain and we want to convert it into frequency domain. In that case, we will use Fourier transform. But for Fourier transform, we should know that signal should be non-periodic or aperiodic. So if we have a aperiodic continuous signal in time domain and we want to convert it into frequency domain, in that case we will use CTFT. Let's say we have a continuous signal x of t and we want to convert it into x j omega, which is actually in frequency domain. X of t is in time domain and x of j omega denotes the signal in frequency domain. For that purpose, we will use Fourier transform. The formula to convert from one domain to another domain is, let's say we have a signal in time domain. In that case, we will use the formula x j omega is equal to minus infinity to infinity x of t, which is our actual signal in time domain, e minus j omega t, and we will integrate this signal according to t. So this formula will help us to convert our signal x of t, which was in time domain, and continuous signal to convert it into frequency domain. We can also convert our signal which was in frequency domain to time domain. So in that case, formula will be like x of t is equal to 1 over 2 pi minus infinity to infinity, which means we will integrate it over the total range x j omega e j omega t d of omega. Here we can see we can convert our signal from time domain to frequency domain and from frequency domain to time domain by using Fourier transform. And this denotes the property of Fourier transform that it is reversible. So if we convert a signal from time domain to frequency domain, it can be converted back into time domain, and both the formulas are given here. By using these formulas, we can convert any signal from one domain to another domain. Thus the properties of Fourier transform. The first property of Fourier transform, linearity, states that if we have two signals x1 of t whose Fourier transform will be x1 omega, and the second signal x2 of t whose Fourier transform will be x2 of omega. In that case, a1 x1 of t plus a2 x2 of t, the Fourier transform of this expression has to be a1 x1 of omega plus a2 x2 of omega. So this is the linearity property of Fourier transform. The second property is time shifting. If we shift a signal in time, it will impact the signal in frequency domain. So let's say we have a signal x of t whose Fourier transform is x of omega. In that case, if we shift this signal to t naught, so the Fourier transform of this signal will be like e power minus j omega t naught x of omega. And if the shift is t plus t naught, in that case Fourier transform will be e power j omega t naught x of omega. So if we shift a signal in time domain, it will impact the exponential power in frequency domain. Similarly, if we shift a signal in frequency domain, it will has its impact on signal in the time domain. Let's say we have a signal x of omega and we shift frequency to omega naught. In that case, signal will be x of t e power j omega naught t. And similarly, if we shift frequency to omega plus omega naught, so the signal in time domain will be x minus j omega naught t. The next property is time scaling. So if we scale a signal in time domain, it will impact the signal in frequency domain. Let's say we have a signal x of t whose Fourier transform will be x of omega. So if we scale this signal to any scalar quantity, let's say x a of t, in that case its Fourier transform will be 1 over a x omega over a. So the scalar quantity will be divided in frequency domain as stated in this formula of Fourier transform is time reversal. As we are assuming that our signal x of t, which is a continuous time signal, so its transform will be x of omega. So time reversal properties states that if we reverse the time to minus t, then its Fourier transform will be x of minus omega. The next property is differentiation in time and frequency. If we differentiate our signal, let's say our signal is x of t and we differentiate it accordingly time, so its Fourier transform will be j omega x of omega. And if we talk about integration, so if we integrate our signal, let's say our signal is x of t, and we integrate from minus infinity to t. So the Fourier transform will be 1 over j omega x of omega plus pi x of 0 and delta omega. The last property is duality. The duality property tells us that if x of t has a Fourier transform x of omega, then if we form a new function of time that has the functional form of the transform x of t, let's say initially we have a signal x of t whose Fourier transform is x of omega. So if we form a new function of time that has the functional form of the transform, we formed a new signal x of t, then it will have a Fourier transform x of omega. So the Fourier transform of this signal will be 2 pi x of minus omega. Now we will implement the Fourier transform in MATLAB. MATLAB provides us two built-in functions to calculate the Fourier transform of any signal. The first one is Fourier, which is used to convert a time domain signal into frequency domain, whereas the second function iFourier is used to convert a frequency domain signal into time domain. So we can explore these options by using MATLAB documentation. To open the MATLAB documentation, we can just type doc and then in search we can search for any function, as we have discussed two built-in functions Fourier and iFourier. So just type Fourier and go for this search result. Here you will find Fourier is used for Fourier transform. You may read its description. Then there are some examples are given. For example, if a function is a rectangular pulse, then you will input commands like this, and MATLAB will show the output results in the form of this expression. Similarly, if you have a unit impulse, the commands will be like this and the result will be 1. Here you can explore many options in the documentation of MATLAB. However, a descriptive table in detail is given in your lab manual. You can see on your lab manual there are 4 columns are given. The first column shows the signal in time domain, whereas the second column shows the results in frequency domain. Third column is used for MATLAB commands. You can check the commands from here, and fourth column shows the result after executing that command. So now we will go for a task. For example, we have a signal x1 of t is equal to exponential power 5t, unit step function is given there, u of minus t. So first of all we need to place or initialize some symbolic variables. As we know, there are two symbolic variables are used. The first one is t and the second one will be omega. So in MATLAB we will put SYMS to initialize symbolic variables t and w for omega. Then we will write our expression. The function is x1 of t is equal to exponential power 5t. So we will write like x1 is equal to exp. As we know, we use exp function for exponential power 5 multiply by t, and then multiply it with unit step. So as we know, for unit step we use a built-in function Heaviside of minus t. So we can write our expression like this for any signal or any function. Now the next task is to find the Fourier transform of this signal. To find the Fourier transform, we need to write Fourier function, and then we will pass this signal to this Fourier function. And omega. After that we can plot this signal, and for plotting we will use easy plot, real values of Fourier transforms, and we will define minimum and maximum range for plotting. As you can see here, x min and x max. Let's say we want to plot it for minus 10 to plus 10. Now we will run this script, and after running this script we can see a plot like this. So this is a plot of x1 signal but in frequency domain. Similarly, we can also find the inverse Fourier of this signal, and to find the inverse Fourier we will use iFourier built-in function. And if we go to the documentation of MATLAB, here we can find the iFourier function, which is used for inverse Fourier transform. In the same way as we had used Fourier transform function, we can also use iFourier function for plotting or calculation of inverse Fourier, which is basically used to convert a frequency domain signal into the time domain.